Today we're going to continue talking about circles. Today we're going to talk about circles and arcs. And our objective for today is to be able to use the different properties of arcs that we're going to discuss in this lesson. We know that if we travel all the way around this circle, there's 360 degrees. Just a reminder to you about that. A central angle. I'm not sure that you will have ever heard of this term before. So in a plane, so you have to be on a flat surface, an angle whose vertex is the center of a circle. So here's the center of the circle. So any angle, like if I went A, T, B, that angle has its center of the circle as its vertex. That would be a central angle. If you notice, the side of this angle is T to A, T to B. Those are radii. That's plural for radius. So an angle whose vertex is the center of a circle is called a central. So that's a play on the word center and central. So let's talk about a couple of the central angles that we see here. We said A, T, B, B, T, C. And if we go straight across, A to T is a radius, T to C is a radius. That would actually be a straight angle there. You should be noticing something that they have in common. All of them have T as the vertex. That's the center of the circle. An arc is simply a part or a portion of the circle. If I travel along this red part of the circle, that's an arc, because that's just a portion or a part of the circle. Or if I travel along this blue portion, that's a different arc of the circle. There's three types of arcs: minor arcs, major arcs, and semicircles. And I think you probably intuitively know what a semicircle is. Semi is half, so you're traveling around half of the circle there. In how do we use arcs? Okay, how do we recognize what we talked about as far as a minor arc? How do we know when we have a minor arc? So let's just read that definition and see what we can do with it. It says, if an arc is in the interior of a central angle, then it is called a minor arc. Now that's kind of hard to understand, but here's our central angle that I have drawn in green. If you think about extending that out, this arc is contained inside the central angle. So this is a minor arc. Okay, now let's talk about the second part here. What is in blue? It says the points A to B and all of the points exterior to the central angle make up a major arc. If you're contained in the central angle, you're a minor arc. If you're on the outside of that central angle, you would be called a major arc. If your endpoints of an arc are the endpoints of a diameter, then the arc is called a semicircle. Right here, this is a diameter. It's passing through the center. This blue is denoting a semicircle. The endpoint here at A, the endpoint at B are on that diameter. So this is a semicircle. Also, traveling this way is a semicircle. A diameter is going to cut any circle into two semicircles. And a major arc is always going to be bigger than a semicircle. So if I can identify a semicircle, that's a good. And then anything bigger than that is going to be a major arc. All right, it says minor arcs are named by their endpoints. Here is the minor arc that's traveling from G around here to F. That's the minor arc along this path. I want to name an arc. I put the two endpoints. It started at G, it stopped at F. and you put an arc around it. That's not a straight line, that's an arc, okay? And so this arc is contained within this central angle right here at GHF. This is minor arc GF. It says the measure of a minor arc is defined to be the measure of its central angle. Now, what that means is if this central angle right here measures 60, this minor arc has to measure exactly the same. So I don't think I really have a place on your paper, but you need to write this. The measure of arc GF is going to be 60 because the measure of the angle is 60. Let's talk about naming some arcs here. It says major arcs and semicircles are named by their endpoints and one point between them on the arc. So if I want to name a minor arc, that would be going from G to F. So my minor arc there would be G to F. I'm going to put that symbol over there. Now a semicircle has to be defined by diameter. Here's my diameter going straight across here. This letter down here should not be there. That's a duplication of E. So my semicircle starts at E. I have to have another point that gives me the direction. I want to travel this way through point G, and then I'm going to stop over here at the other end point of my diameter, which would be F. A semicircle has to have its two endpoints, but right in the middle has to be a middle letter that gives me the direction that I'm trying to go in. Because for that semicircle, I have two different directions I could go. So that middle letter tells me direction. All right, a major arc. A major and minor arc are named in the same way. If I want to name a major arc here, I need to name a shape that is bigger than a semicircle, an arc that is bigger than a semicircle. So let's go back over here and see if we can find one that's bigger than a semicircle. If I go E around, F would be a semicircle and keep on going past that. So starting at E to F to G. Started at E, F gives me my direction, and G tells me where to stop. And that's a arc. I'm sure you can do much better than I did on writing that. All right, it says that E, G, F is a semicircle, and we just talked about that in the previous slide. We understand that E to G to F is a semicircle. And you need to remember that the measure of a semicircle is always 180. Semi means half. Half of a circle is going to be 180. Now, what about the measure of a major arc? I think the minor arc's easy to understand. The semicircle is easy to understand. But how do we find the measure of a major arc? The measure of a major arc is defined as the difference. That means you're going to be subtracting something. The difference, 360, and measure of the minor arc that's associated with it. So if I'm trying to go from E to, if I'm trying to go from G to E to F all the way around here, and I want to know the measure of that major arc, you start with 360, it's going to be subtraction. And what's the minor arc that isn't included in this? That's 60 degrees. So it's 360 minus 60 would be 300. So the measure of the major arc is 300. It says find the measure of the arcs in this problem. Now, what I would do is try to figure out what measures I'm seeing here. Here's a diameter. So this is a semicircle, or this is a straight angle. These two angles are supplementary to each other, just like they always have been. The fact that these are drawn in a circle, that it doesn't matter. It's still two angles that look just like this. The one on this side is 80. The one on this side is 100. MN is a minor arc. Where's the angle that's associated with it? The minor arc is associated with an 80-degree angle. I want to go from M to P to N. That's major. This is major. So it's everything is 360 minus the minor arc. So 360 minus that arc would be 280. And then I want to go from, what is it asking me to do? It's asking me to go from P to MN. P to MN. So I know that that's either a major arc or a semicircle. P through M and stop at N. That's half of a circle. So that's 180 degrees. Right. Now the slides are going to explain that a little bit more, but I wanted to go through that with you. So it says find the measure of each arc. MN's minor, so it's got to be 80. MPN is major, so we're doing that arithmetic of 360 minus 80 and getting 280. And we're going to find the measure of PMN. We know that that's a semicircle, so it has to be 180. All right, it says name the following in P. It says name some minor arcs. So while you were doing this in your notes, you should have tried to name some minor arcs. We'll just name a few together. Q to R would have worked. R to S, anything that's less than a semicircle works. S to T, T to U, U to Q. I could have even gone U to R. That would be minor arc because that's less than a semicircle. I could have gone T to Q. I could have gone S to U. I could have gone S to, did I say Q to T? So there's several minor arcs you can name there. Major have to be bigger than semi. So let's talk about semicircles first. I have to see a diameter. There's a diameter. So on this side, RST is a semicircle. On this side, RQT, or I could have named that RUT. So those are semicircles. Here's another diameter. It could be QRS, or I could call this QUS, QUT. That's the same semicircle, but two names. And then let's talk about major arcs. If I'm following along this circle, I have got to go past the semicircle position. So Q to R to T would make it a major arc. I could go R to Q, can't stop there, to S. I could go Q, S, U. There's many semicircles and major arcs and minor arcs that you can draw here. It says find the measure of each. Now if you notice, some of them are arcs. Some of these are arcs, while some of them are angles. So maybe we should start with the angles. It says find the measure of ZAY. That's just a central angle, ZAY. Well, that's 103. So we got that one. And then down here is XAY. Okay. I think I need to mark some things on my picture before I try to go much further. This is 90 because it's marked that way. This is the other side of that straight angle. So this is 90. These two angles are supplementary. Here's that straight angle. So that means this angle is 77. If you mark your angles, remember your arcs are the same as the related central angle. So now I'm using these angles as my guide. X to Y. X to Y has to be 77. W to Z has to be 90. Y to Z was 103. W to X is 90. And angle XAY is 77. If you know your interior or central angles, your measures are the same. This is the only postulate that we have in this lesson. First thing we need to talk about is a little bit of vocabulary, and it's the word adjacent. It says, if two arcs of the same circle are adjacent, if they intersect in exactly one point. Adjacent means the same thing for arc as it did for angles and segments. This arc from A to C and this arc C to B are adjacent because they have that point C in common and no other points. So postulate 10.1 says the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So if I wanted to talk about the arc that goes all the way around from A to B to C, I would add these arcs together, just like the segment addition postulate, just like the angle addition postulate. We have a arc addition postulate. It works the very same way. Now it says we want to find the measure of the arcs in this picture. We want to find F to G. Well, there's 360 degrees in a circle. I think I can figure out how many degrees needs to go right here. I've got 40 and 80 and 110, so I think that's 230 degrees right there. That's 230 degrees. So if my circle only has 360 degrees in it, that means this central angle's got to be 130. Now if I fill in all my missing central angles, that's going to help me. Okay, how much is it from F to G? Going this way, it is 130. 130. If I want to go G to E to F, G to E to F, I'm traveling all the way around here. That would be those angles that I have highlighted or in blue, the measure I have given here in blue. And so that measure we said adds up to be 230. And then if I want to go G to E is 40 plus 80, which would be 120. This is that answer right there. G to E would be 120.